For this part of the lesson, we're going to talk about deconstructing when we have an inequality rather than an equation. And so I went ahead and filled in the construction and deconstruct story, so take a minute just to do that. We're going to work through this problem exactly how we worked on through the equation problems and the ones that you posted. And then we're going to talk a little bit more about why this is different than having an equation. So we start off as we've done before. So I'm going to start off with the inequality. And our inequality in our deconstruct story says we're going to subtract 5. And when we subtract 5, we know that we're going to end up with a product. And so here's our product. So we know that we're going to end up with the product of this sum. And we know that that's going to be 6 here. So then we're going to divide by -2, and when we divide by -2, we're going to end up with the sum, and here's our sum. So we see that 6a plus 1, the sum, is going to be less than -3. And then it says to subtract 1, and so when I subtract 1, I'm going to end up with a product, and my product is 6a, and that's going to be -4. And then I divide by 6, and that's going to leave us with a. And so when I divide by 6, I get -2/3, or we could say -6.6 repeating, although -0.6 repeating it is going to be a little bit harder to check, where if we leave it as a fraction, it's going to be much easier to check. So now this time, rather than just a solution check, we're checking the solution set. And keep in mind that when we have an inequality of any kind, this comparative statement, then we're talking about a whole bunch of numbers that satisfy the statement, not just a single number like as in an equation. And so I want to first check to make sure I did the -2/3 correctly, and then I want to check values in which a would be less than -2/3. And so I'm going to do 2 checks over here. And so I'm going to have -2 times 6 times -2/3 plus 1, parentheses, times plus 5. And we want to see if, actually we're going to see if this is equal to 11, because that's what this is actually telling us. So 6 times -2/3, so I have 6 copies of -2/3. Well, if 1/3 times 6 is going to give us 2, then 6 copies of -2/3 must give us -4. So we have -2 times a -4 plus 1 plus 5. And we want to see if that's less than, actually we want to see if it's equal to. So -2 times -3 plus 5. And then we have 6 plus 5. And that, in fact, is 11. It's not 11 less than, but it is 11 is equal to. So we know that the value of -2/3 is correct. And again, you can see these values. So we started with -2/3. The -4 sits right here. The -3 is this solution. The 6 lives here. And the 11 is what we're looking for. But then we also want to look at values where a is less than -2/3. So if we just think about a number line real quick, and here's 0, here's 1, here's -1, so -2/3 lives someplace right there. We want a number less than that, so I'm going to just pick -1. It's an easy number to check. So when you go through the process to check -1, we'll see that we end up with 15 is less than 11, which is not a true statement. So we know that the value of -2/3 is correct because we got it to check correctly here, but a value less than -2/3, say -1, is not correct. So that must mean we messed up someplace, but we messed up with the direction of the sign, not with our numerical calculations to get -2/3 to be the value of what a would be if it was equal to. So I want to move forward so looking underneath what we just did, if we look at these webs again, and so if we have -7 is less than 10, and if we subtract 4, add 1, divide by 2, and multiply by 3, so these are all positive values, And so do we end up with true statements? So if I add 1, I'm going to get negative 6 is less than 11. That is correct. Negative 21, is that less than 30? Yes, that is correct. If I take negative 7/2, less than 5, that is correct. A negative number is always less than a positive number. And now if I subtract 4, that's going to give me negative 11 is less than 6, and that is also correct. So working with positive values and doing every one of the 4 operations, we always end up with a true statement. So now if we look at these negative numbers, or negative values, and do the 4 operations, we're going to have, now we're going to add a negative 3, and so that gives us negative 10. Is that less than 7? Yes, that's still correct. If I take negative or positive 35 now, is less than negative 50. That is not correct. And then if we divide here and we get 7/4 is less than negative 10/4. Again, a positive number has always got to be greater than a negative number, so that's not correct. And then if I subtract a negative 2, that's going to give me negative 5 is less than 8, and that is correct. So we see that the only time that we have something that is not true is when we multiply or divide by a negative result. Okay, so this is going to be key when we go back and talk about what we need to change in our deconstruct process. So in our definition box, we want to say when multiplying or dividing by a negative number, negative value or negative number, the direction of the inequality and inequality sign, if you want to put here, must switch to keep the statement true. This statement becomes part of the deconstruct story. So in other words, if we go back to the very beginning, the problem we had initially, we will see that in our deconstruct story, we are dividing by a negative number. And so in that moment, we also need to say divide by negative 2 and change the direction of the inequality Now you notice here we're dividing as well, but we're dividing by a positive number, so we do not change the direction of the inequality, only if we divide or multiply by a negative number. So it is in this moment, when we divide by negative 2, that this inequality sign should have said greater than, and then that would make this one greater than and this one greater than. So we really want to check to make sure that there's a value greater than negative 2/3. So I'm going to check 0. And when I plug 0 in, I'm going to do it down here, negative 2 times 6 times 0 plus 1, and we're going to plus 5, and we're going to see if that's less than 11. And so now we have negative 2, and then this is 6 times 0 plus 1 is just 1, plus 5, is that less than 11? And now we have negative 2 plus 5, is that less than 11? We have 3 is less than 11. This now checks. So our correct answer is A is greater than negative 2/3 not less than negative 2/3.